Hello, my name is Bittar. I am in Team 9, and this is my 4-bit full adder subtractor circuit. The limits to the circuit is as follows. When you add two positive numbers, if the sum is greater than or equal to 8, you get a wrong answer due to overflow. If you add two negative numbers, if the absolute value is greater than 8, you also get a wrong answer due to overflow. For my circuit, this switch controls input A, this switch controls input B, and this switch controls my carry-in bit. This LED is my most significant bit, and this LED is my least significant bit. I have 4 addition examples and 4 subtraction examples that I'll use to showcase my circuit. I'll start with the first addition example, where A is greater than 0 and B is greater than 0, where A equals 2 and B equals 2. So 2 plus 2 should equal 4. So first, I'll set A equal to 2. There we go. Now I'll set B equal to 2. So 2 plus 2 is equal to 4, which is correct. 0, 1, 0, 0 is 4. So for my next example, addition example, A is greater than 0 and B is less than 0, where A equals 2 and B equals negative 1. I'll first set B equal to negative 1, then I'll set A equal to 2. There we go. 2 plus negative 1 is equal to 1. So that works. For my next example, A is less than 0 and B is greater than 0, where A equals negative 1 and B equals 2. I'll first start by setting A equal to negative 1, then I'll set B equal to 2. And again, that is 1. Negative 1 plus 2 is indeed 1. For my last addition example, A is less than 0 and B is less than 0, where A equals negative 1 and B equals negative 1. So, negative 1 plus negative 1 should result in negative 2. I'll first start by setting A equal to negative 1, then I'll set B equal to negative 1. And we get negative 2. 1, 1, 1, 0 is indeed negative 2. So that concludes the addition examples, and I'll move on to the subtraction examples. To start my subtraction examples, I'll set my carry-in bit equal to 1. Okay, now, for the first subtraction example, A is greater than 0 minus B greater than 0, where A equals 2 and B equals 2. So 2 minus 2 should result in 0. All right. So first I set A equal to 2, then I'll set B equal to 2. 2 minus 2 is indeed 0. For my next subtraction example, A is greater than 0 minus B less than 0, where A equals 1, B equals negative 1. 1 minus negative 1 should result in 2. I'll first start by setting A equal to 1. Now I'll set B equal to negative 1. So 1 minus negative 1 should be 2, and that is what we have. 0, 0, 1, 0 is indeed 2. For my next subtraction example, A is less than 0 minus B greater than 0, where A equals negative 1 and B equals 2. So negative 1 minus 2 should result in negative 3. I'll start by setting A equal to negative 1. Then I'll set B equal to 2. So negative 1 minus 2 results in negative 3. 1, 1, 0, 1 is indeed negative 3. For my last subtraction example, A is less than 0 minus B less than 0, where A equals negative 1 and B equals negative 1. So negative 1 minus negative 1 should result in 0. I'll start by setting A equal to negative 1, and then I'll set B equal to negative 1. And there we go. Negative 1 minus negative 1 is indeed 0. So that was my circuit with all the examples. It worked for all the examples, and that's good. That's what we want. Thank you for the presentation. Have a good day.